Sorry for breaking. So we are here in this model. So let's see that there are dots. I think it is a data and which comes by the equation, and this is classifier. And let's see the difference in more performing. So just what we have done, we have like created our equation, and now let's see. We will implement linear regression. So it is a sklearn library from where we will import linear regression. And in linear underscore reg equal to linear regression, so it takes all the functionality of linear regression in linear li and reg. And then we will do fit operation. So what it will do, fit operation, so there is x comma y. Okay, so x is our training data and y is the output. X is like the features and y is output, so we train x or comma y with respect to the y feature. Like are you able to understand? Like see, we have a one equation, we have created a one equation with our noisy parameter. And so are you able to understand what we are going to do? So see, like, there was first equation, you have seen y equal to 3x plus 4. Okay. And so what we did, we little bit we polluted that equation, and then uh, we generated a parameter theta, and then again we created the equation by that parameter. And now we are going to check like how much our parameter is able to reduce the error, because both are different line. Okay, so let's see how much it happened. So it will train x matrix with respect to y output. Linear regression dot intercept underscore comma linear regression dot coefficient. Okay, let's see what this line does. Linear regression, intercept and linear are attributes of linear regression. So they are attributes of linear regression object in scikit-learn, which represent the intercept, that is bias term, and coefficient, that is weight. Attribute or object in which represent the intercept, that is bias term, and coefficient. So it represents the intercept, means theta naught, and this are linear coefficient, theta and theta 1 to theta n. Okay. Linear, it returns a single float value representing the intercept of a linear regression model. This value indicates the predicted value of the target variable when all the features are zero. Okay. And linear regression coefficient return an array of float representing the coefficient weights of linear regression model. Each element of array correspond To the weight of a single feature representing the coefficient, that is weight of linear regression model. Each element of the array correspond to the weight of single feature in the input data. So this produce only one value 2.770. Linear underscore reg dot intercept underscore comma linear underscore reg dot coefficient. So run these lines, see what happens. Why? So see, it is a single value. Theta naught is again 4.2, and see array dot o. It's again 2.8, which is very close to 3. And now we have checked. Now we will like predict x new and see how much right it will predict. So 4.0, which is very, for me, I don't know why it is very accurate. 4.0 and 9.7 x new. What is was the x new? So it got was a concatenated one, right? 1012 linear regression predict x new 4,9 on the cp dot line dot its function. The name stands for least square line algorithm dot lsdsq function. The name stand which you could call directly theta underscore bed underscore svd comma residual comma rank comma s equal to nv dot lineal g. It's very strange name, like I'm not able to understand even. Stand. Let's see what ChatGPT is telling. np dot lineal g dot istsq is a numpy function that compute the least square solution to a linear matrix equation in the code you provided. Is a numpy function that computes the least square solution to a linear matrix in the code you provided. X comma v by takes three argument. And the feature matrix with the bias term added, that is the design matrix. Y the target RCOND, the threshold value below which singular value of the feature matrix are considered zero. This parameter is optional and default to none, which means it's set to pawn in numpy only dimension. Theta best SVD at least square solution to the linear equation x dot bot theta equal to y using the singular value decomposition SVD method. The least square solution to the linear equation. The least square solution to the linear equation. Okay, x underscore b dot theta equal to y computed using a singular value decomposition SVD method. This is equivalent to the solution of obtained using the normal equation method theta best when the feature matrix is invertible, that is has full rank. Residual, the sum of square residual SSR of linear equation which represent the difference between the predicted value and the actual value of target variable. The sum of squared residual of the linear equation which represent the difference between the predicted value and the actual value of target variable. A smaller SSR indicates a better fit of the model to the data. Rank, the rank of feature matrix x underscore b. This is the number of linearly independent rows or column of the matrix which determines its dimensionality in invertibility. If the rank of the feature matrix, and this is the number of linearly independent rows or column of the matrix which determines its dimensionality in invertibility. If the rank is less than the number of columns, that is, its feature the matrix is said to be singular or degenerate, and the linear equation may have no unique solution. As is the singular values of the feature matrix x underscore b sorted in descending order. These values represent the square root of eigenvalues of x underscore bot b dot x underscore bot dot t, which determine the spread and orientation of data in the feature space. For example, suppose you have a feature matrix x underscore b and the target vector y, and you want to compute the least square solution and sum of squared residual using np dot line alg dot lstq. You can do. I mean, I'm not able to even understand what this all things are. I have to go deeper in these things, I think now. These are very tough function for me now. The print the singular value of the feature matrix. The linear equations is theta best SVD 2.21, which means that predicted value the target value is given by 2, where x1 and x2 are the values of first and second feature respectively. The sum of squares is very small. Fits the data very well. The rank of the feature matters too, which means it has full rank and it is invertible. The function compute x theta cap equal to x the pseudo inverse of x, especially the Moore-Penrose inverse. You can use np dot line ap lpg dot p environment to compute the pseudo inverse directly, and p dot line alg dot pnv. The pseudo inverse itself is computed using a standard matrix factorization technique called singular value decomposition that can decompose the training set matrix into the matrix multiplication of three matrix. Use summation v transpose c numpy dot takes